So first off, I want to go over just some basics that we talked about. One, how do we know what the degree is of a polynomial? Go ahead, Paige. Okay. The highest exponent is the degree, correct? How do I understand what the turning points are? Remember? Yes, sir. Okay, so it depends on, first off, our degree, doesn't it? So if I had degree 3, how many turning points can I have? 2 or 0. Remember, we go 1 less than our degree is the most turning points we could have, correct? And then we go down in increments of 2. And I believe on our question, on question 15 is a good analysis of that. It says your friend claims the graph of the function y equals 4x cubed plus 4 can only have one turning point. Why is that a false statement? Well, first off, what does the end behavior of an x cubed look like? Remember, nope. Something of that case, doesn't it? Right? Okay. If I only had one turning point, there's a turning point. What happens though? Because I only have one, would I have the same end behavior as a x to the third? No. Okay? So hence why we go down in increments of 2, so that we can get the same end behavior. Right? So for example, if it was x cubed, remember we could have 2 turning points, correct? Or we could have 0. Because this is always increasing, isn't it? So therefore, there's no one turning point, or we wouldn't have the end behavior required for an x cubed. We don't know, unless we graph it. Okay? So I cannot tell just by the equation. Now, a little bit later, we're going to figure out some more stuff. But as of right now, no. Okay? But what is the possible turning points? It'd be 2 or 0. Okay? Is everybody there with me? Any questions? Does that help a little bit? Okay, end behavior. What is the end behavior of, okay, if I wrote negative 3x cubed plus 4x squared. So what I first do is look at the degree. The degree is 3. So this is an odd degree, correct? So therefore, we have the end behavior so far right now, just as the x cubed would look like this, correct? Starting as x goes to negative infinity, I should be going down. As x goes to infinity, I should be going up. But then I look at the leading coefficient. The leading coefficient is negative 3, isn't it? Correct? So what does that do to my end behavior? It flips it, correct? You guys see how we can determine what the graph might look like in basics just by degree and leading coefficient. Once again, what does any even look like with a leading coefficient that's positive? It should be going up. As a negative leading coefficient, it should be going down, correct? So we don't know exactly what the graph looks like, but we have a general idea of what the end behavior looks like, correct? So for us, I know that this basically has something of that case. Now, it could have 2 turning points, right? But I don't really care right now because I'm asking about the end behavior. Now, how do I write end behavior? As x goes to infinity, what is happening to my y value? It is going to negative infinity. As x is going to negative infinity, what is happening to my y value? It is going to infinity. Okay? So far, so good. Any questions there? All right. Now, in some of your questions, it asks for where it's increasing and decreasing. We talked a little bit about this. Remember how we talked about going to the mountains, right? If I got to the highest point, am I increasing anymore? Because as soon as I get to the top of the mountain, I'm no longer increasing, am I? Now let's say I get to the top of the mountain, I'm steady ready to go home. As I start walking down, at the very top, am I decreasing as well? So we don't include the peaks, right? But they go up to that, but not including, correct? Let's go ahead and do this together. So once again, if you have a calculator, and as I was working with Miss Isabel yesterday, if you don't have a TI 83 or 84, you're more than welcome to still do all this stuff, but you might have to observe it at home or come and visit me and we can work together to figure out how to do it. But I can't spend the time in class to work with you because that's a lot of time for me jumping back and forth. So even if your TI 84 or 83 doesn't look like where I am, that might be because it has some different settings going on. I can help you after school or something of that case. Everybody with me? Yes, sir. Same thing with her. That's what you're going to have to be looking online. And it helps. Like we just yesterday, I didn't know how to graph finding the max and min, but we came in, she came in, we Googled it, we watched the video, and we found it out. Pretty self-explanatory after we looked at it. Okay? All right. So let's go ahead and we're going to graph y equals, this is basically a y equals, right? Same thing. Okay, so I'm going to pull up my calculator really quick. Now, just to let you know, I don't know exactly when our first test is because we go all the way through 1-6. But on our first test, understand you might want to have at least a graphing calculator on that day. For at least a couple questions, okay? Any questions? All right, here we go. That's as big as I can get it, but here we go. So I'm going to hit y equals. I already have an equation in here. I'm going to clear it. Okay, so I'm all the way at the beginning. Y equals, if you have something in your y equals, go ahead and clear it out. You hit your graph button. I forgot your name already. Help me name right here. Braden, Jensen. Braden, if you hit your graph button on your calculator, and then there should be a y equals. All right. So what was my equation? Negative 3. Notice here's my x value right here. Was it cubed, right? So I'm going to do caret cube. Oops, didn't get it over there. Okay, I'm going to push over. Then it is, was it plus 4x squared? Is that what I wrote down? Plus 4x squared. Okay, is everybody with me there? Did everybody put that in there? Y equals. Even if you have a TI 83, you should be able to do it. It just doesn't put it up into the high point, right, when you do your caret, correct? Okay. With that being said, I want everybody to have the same view. So I'm going to hit zoom number 6, where it says zoom standard. What that is a negative 10 to 10 window, negative 10 to 10 window. Is that always the best window for every graph? No, you might have to adjust your graph, and that's actually what a window does. Does that make sense to everybody? All good? Okay, now, understand here, let's go ahead and really quickly, just so I can write on this, notice we have a low point right there, and we have a high point right there, don't we? As we look on your own graph, correct? So I have a max and a min point, don't I? So I have what we call actually a relative min, because is our lowest point where I hit that low point right there? Our lowest point is actually negative infinity, isn't it? That's our minimum. So we actually call this a relative minimum, meaning it's a minimum within that specific region. Okay? And we have a high point. Okay? I would like to go ahead and find the coordinate of this low point. Okay, so let me show you how you do that. You guys see above trace it says calc. Okay, so you're going to hit second, second calc. What am I going to look for? Remember, that was a low point, wasn't it? So that is a minimum. So that's a number 3. All right, in our case, it says left bound. What does that mean? It says, okay, go to the left of that minimum point. So I'm going to push over and notice your cursor is going to move. See if you'll see my cursor is right there. Okay, so you want to go to the left of it. Then I hit enter, as long as I know I'm to the left of it. Okay, now what's our next instruction? Right bound. Now you just want to go a little bit to the right of it, and I am. I hit enter. And then our last thing says guess. Just hit enter again. And it gives us a point. And that point on mine says 0.23 blah 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 e to the -7th, which is basically 0. Sometimes your calculator has such small decimal points, okay, because of it, it'll do these things, and I don't understand why, but really this point is 0, 0. Did any of your guys' calculators come up 0, 0? Awesome. And some of you guys might have the same stuff I did with the 2 point blah 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 e to the very small number, right? If it ever happens like that, or if it does, what if it happens like 1.99999 e to the -100th, or e to the 100th? That's just basically 2. Just be aware, okay? Does that make sense to everybody? So this coordinate, I'm going to come back here, okay? So this graph, which was y, whoa, that's not what I wanted. Y equals -3x cubed plus 4x squared. Once again, basically looking like such, correct? That's just a basic sketch of our graph. You guys all agree with me? Okay, has a point of 0, 0. And then now we're going to find this high point. Okay? Everybody understand what I'm trying to do? Okay, so then I come back over to my calculator. I'm going to find the high point. Where do I find? That's going to be a maximum, isn't it? So I do the same thing. I'm going to hit second trace, which gives me a calculate button. Use this a lot. Okay, and if we look down at the fourth one, it says maximum. Hi, Trevor. How's life? Why is everybody in freaking suits today? Why? What if you didn't own a suit? Because I hate suits. God doesn't even get a tie sometimes. You know what I mean? I like to go to church with just a button-down shirt. Yeah, that's awesome. Do so. Okay, now notice our instructions here. Once again, it says left bound, meaning I am to the left of that 0. I already have my flashing. I'm already here. So I'm going to hit enter. Then it tells me right bound. Once again, yours doesn't do that, right? You just have to get close to it. And after so does yours. Yours is just basically somewhere over there when you figure out how to do it, just jump online and say how to find max and min on it. So then we come over here. And we are to the right of that high point, so I hit enter. Now for me, that says, I really can't see, 1.27, comma, or we could go 1.28 if we round to the 100th, comma, 2.8, okay, or 2.28. So, coming back here, this high point was at 1.28, comma, 0.28. Would you agree with that, Trevor? Is that what it was? Is everybody there with me? Any questions on how I found it? Because if you do, this is the point that I need to help you. Okay? Yes. You're all right there. You might have to look at it a little bit later. Okay, so, ladies and gentlemen, This part right here, from negative infinity to that point, what are we doing? Increasing or decreasing? Decreasing. Notice as we're moving to the right, our x, our y values are getting smaller, aren't they? So we have two different parts. We have increasing and we have decreasing. The first part we have is decreasing from negative infinity to 0. Now, what 0 am I talking about? Am I talking about the x value or am I talking about the y value? I'm talking about the x value. Okay, because from negative infinity for the x to 0, my y values are decreasing. Makes sense. Okay, do we have another decreasing interval? From where? From 1.282 in not negative infinity, that's going down. Remember, it's our x's. Yes, please. From 1.28 to infinity, that graph is decreasing, isn't it? Remember, when you have more than one, you put a union sign. What is the intersection? A union is an or, meaning it is decreasing here or here. Right? Both of those sections are decreasing. Now, once again, why am I parentheses instead of brackets? Because once again, when I get to the bottom of the hill, or I'm climbing downstairs, and I get to the bottom floor, am I decreasing anymore? When I'm at the top of the mountain, hi Shaylee, when I'm walking from the top of the mountain, as soon as I start, when I'm at the top, I'm not decreasing, but as soon as I start, that makes me decrease, correct? So it's from that point up to there, but not included. Makes sense. Where is it increasing from? 0 to 1.28. Okay? Yes, no, maybe so. Well, we're feeling good. Does that make sense how to use your calculator? Find the intervals of where it's increasing and decreasing. Now, yes, sir. Okay, awesome. Maybe me and you'll work on it a little bit later if that's okay. Okay? Just so I can continue on. But if we are, but you got the idea of at least how to do so. All right. Any questions so far? All right. Now, is every graph going to be within a 10 by 10 window? So you might have to adjust it. Let's go ahead and adjust the graph just so you guys get an understanding of how to do so. Okay? Maybe I wanted to make this a little bit better. Maybe I want to come in and zoom in a little bit. Maybe negative 10 to 10 and negative 10 to 10 is too big. Okay, so I hit window. What does X min mean? The lowest our X value is going to be. How about we do that as negative 5? Okay. X max, what's the highest we want to be? How about 5? X scale, what that means is what increment is each tick mark? Each tick mark is every 1. Does that make sense to everyone? And then I think we could go negative 5 to 5 again. And then let's hit graph. Notice we can just get a little bit better picture of what that graph is, right? Now that's adjusting your window. And sometimes you have to think about it. I believe one of your questions is talking about a box, right? Trying to make a box or something of that case. And it says on number 27. It says write an equation of a volume of a box that has a length 5, a box with a length that is 5 inches less, or 5 less than the width, and the height is 3 less than the width. So really quickly, I'm going to hurry and draw a box. I suck at boxes, so I'm not an artist, people. Oh yeah, people, check that out. I just made me a box. Okay, here's my width. it said our length is 5 less than that, right? How do I write that? W minus 5. If I called him W, it'd be W minus 5, right? What would be our height? I think it said 3 less. Is that correct? So this would be W minus 3. So once again, what's the volume of any cylinder? Your base times your height. So W, by the way, so I just go W times W minus 5, W minus 3. Do I have to plug this in and make it a polynomial? Right now this is in linear factors. I do not have to do it as a polynomial because your calculator would do that for us. Well, let's think realistically. What's a good reasonable amount to have for your maximum width? We could go up to 30, couldn't it? So you might want to adjust it all the way over to 30. Now our height, our volume might get pretty high. It might be bigger than 10, huh? So we might want our height to go up to 200, right? So let's just graph this one more time, just so we know. So y equals, instead of W, what am I going to be using? X, so I have X, parenthesis, I think it was X minus 5, is that right? Parenthesis, X minus 3 as well, right? Okay, I'm just going to show you what the graph looks like with our negative 5 to 5, and you guys tell me if it's a good window. Here it comes. That sucks, doesn't it? Okay. So what can we do? What do we probably want to go a little bit more in our x's, don't we? And a little bit higher in our y's. So I'm going to go to window. Let's do our x min was pretty okay. Let's do our x max over to 20. Let's do our y min at 30. And give it a shot and hit graph. There we go. All right. Now, what is this representing? What is this graph representing? It's representing volume. Okay. Is that correct? Representing volume. So, with that being said, notice what's going to be the one that maximizes my volume. Where is that at? That point right there. That x value or that width is going to maximize my volume. Okay? Is everybody there with me? Any questions on that? Or it might ask, where is the volume increasing? Where is it decreasing? I think that's what it asks, doesn't it? 27. So then you want to find that high point and that low point, don't you? Okay, is everybody with me on that? Understand kind of what we're doing there. How does that feel to give you a better, does that help you think to help out on your homework a little bit more decisive? Okay? Now, the other thing that we actually covered in class was differences. Okay, we did one example, I believe. Let me get rid of this. Okay, we did one example of differences. Okay? Let's do number 8 as a class. Can you read me the numbers on number 8 for the x values, please? And what goes with -2? This is -15?
Yeah, sorry.
Oh, you're okay.
-9, -9, -9, and then
You okay there? Agree with me on that. Okay, we're going to find our differences. Now, recall, your class actually got to this, didn't we? We did one example. What if your first difference has a constant? Then that means it is linear. What if your second difference is constant? That means it is a quadratic. What if your third difference is it? How about fourth? Fourth, and so on. Okay, makes sense. Okay, so we're going to go here. Does everybody confer with her? These are the numbers that was given. Number 8. Not saying you can't read them, but just want to make sure. How does negative 15 get to negative 9? We did up 6. Everybody understand that? We went higher 6. How about negative 9 to negative 9? How about negative 9 to negative 9? How about negative 9 to negative 3? Up 6, didn't we? So, on our first difference, is it the same? So this is not linear, is it? Okay, let's try our second difference. How does 6 get to 0? We went down 6, didn't we? How does 0 get to 0? We went 0. How does 0 get to 6? We went up 6. Is our second difference the same? So therefore, this is not a quadratic. Let's try our third difference, which is going to work. How does negative 6 get to 0? We went up 6. How does 0 get to 6? We went up 6. Oh, look at that, ladies and gentlemen. There's a constant on our third difference, so therefore this is a cubic, which means degree 3. Okay? With that knowledge, do you guys believe you can finish 1-1? Okay. We're going to let you guys hold on to this. Okay? We're going to turn it in next time. So 1-1 and 1-2 will be possible questions for your bell quiz on Wednesday. Okay? 1-1 and 1-2 will be possible questions for Wednesday. Yes. So what I would do, anytime I like to do a chart, I like to do -2 to 2. And then you plug those in for the x values to get your y values that correlate with them, and then do your difference. Okay? All right. So if you guys will quickly put that away, though, just so that we are concentrating on the new subject at hand. Okay? One dash 2 is adding, subtracting, timesing, and dividing polynomials, which I'm not spending any time on. Because we also know how to add polynomials, what do you have to do? Combine like terms, right? When you subtract polynomials, what do you have to do? Combine like terms. When you multiply polynomials, what do? You FOIL, which is called the distributive method, right? Agreed? And then what do you do after the distribution method? Combine like terms. Okay? How do you divide polynomials? Well, we aren't really all the way there yet. So let's say I have f of x equals 3x squared plus 2x minus 7. Not a system, no. And g of x is 4x minus 3. How do I divide f of x by g of x? Well, here we go. Not hard. Ready? You guys all ready for this? Mind blowing. Woo! Get excited, people. That was so hard. Dang. Was that really bad? They don't even ask us about domain yet, I don't believe. Just make sure, Krista, hand me that 1-2 over there in that box, if you don't mind. Say again? That's a free dingleberry. You guys all know what dingleberries are, right? Poop that hangs on the animal's bum. Bulls have dingle taste. Some guacamole with those chips. Is that a little too much? I'm just seeing Look at this. Look at us, guys. We're kicking traps. We're already. I love it. All right, we're done with that part. Now, we're going to get into even and odd functions. Hey, gentlemen. So, even and odd functions. So, an even function does not have to do with its power being even. Oh, hi, thank you. I'll just pay into it, $30, right? Thank you. Appreciate it. Did you get my email, Mike, about sharing the information? Yeah, okay. Thanks. All right. So even function, ladies and gentlemen. It doesn't necessarily mean it has to have an even power as its degree. That doesn't necessarily what it means. What it means is if I have f of x, a regular function, okay, and I replace f of x with the opposite x value. That's what that means, opposite x value, right? If I replace x with negative x, and it comes back with the exact same function, that is an even function. Now you might be like, what the heck is he talking about right now? Because I haven't shown you. But that idea makes it an even function. I have a regular function. If I replace the x with a negative x and it comes back to be exactly the same function, it is even. Okay? Is everybody with me on that? All right. So let's start with an example. Now, like I said, it doesn't necessarily mean that it has to have an x squared, but let's just start with y equals x squared plus 4. We'll make this an f of x, actually, just so we can use the notation that we used above. Now, just to be aware, for those people, do you need something, Shay? I'm going to be a while. Okay, what's up? What if I wanted you to find f of 3? How would I do that? What does that 3 represent? X, and so therefore in the equation, anytime I see an x, I replace it with a 3. Input, output's a function, correct? You guys agree with that? Remember that? So this would be 3 squared plus 4, which is 9 plus 4, which is 13. Just to remember how to plug it in. Okay. But remember, once again, here's our equation. Is this an even function? So how do we prove that it is? We replace x with negative x. Okay? From Alabama. Okay, so I replace that x with a negative x. And anytime I really replace something, I put parentheses around it, okay? Is everybody there with me? What is negative x squared? Negative x squared. Doesn't it come back to x squared plus 4? Does it come back to its original function? It does. So therefore, it is even. It's an even function. Okay? To be honest with you as well, if it is an even function, how many of you guys remember what x squared plus 4 looks like as a graph? What happens? It has our x squared graph, and then what does the 4 do to it? Shifts us up 4, doesn't it? You guys remember that? So it looks like this. Okay? If you'll notice, an even function is symmetrical. Is that how you spell it? I suck at spelling. It's close enough, if not. Symmetrical to the y-axis. Meaning, if I folded the graph on the y-axis, would it lie upon itself? Yes, it would. So if you're ever looking at a graph, you can tell whether it is an even function if it is symmetrical about the y-axis. Okay? Any questions on that? Okay, odd function. Odd functions. Odd functions, you do the same procedure. So I have my f of x function. I replace it with negative x, just like I would have done with the even function. But it doesn't come back to be the exact same. It comes out to be its opposite. Okay? I just want to get some better examples. This is really the big part of our lesson today. I'm going to push pause just for, well, I guess we can do it. Here we go. Let's do one. Here's a function. Okay. Very similar to our last one. Notice this is something raised to an odd power. But just because it's raised to an odd power doesn't necessarily mean it's an odd function. You remember just the same way with if it's raised to an even power, doesn't make it necessarily an even function. Okay? Is this an odd function? Will you guys take the time to go ahead and try that on your own? Is it going to be directly opposite? So I want to ask you guys first, what would be directly opposite of this function? What would be its opposite? Negative x cubed minus 3. That would be its opposite. Notice I just go ahead and take the function and I times it by a negative. Make sense? Go ahead and try that, please. See if it comes out to be this. Once again, was it an odd function? Let's try. F of negative x is negative x cubed plus 3. Okay? Negative x cubed comes out to be what? Negative x cubed, doesn't it? Just without the parentheses. I know it looks awesome. Plus 3. Notice this term switched, but did this guy. So therefore, is this an odd function? No. What if it was just f of x equals x cubed? Would it be? In this case, it would, wouldn't it? Because, give me 1 second, Jared. Which would be directly opposite of what it was, right? Okay, go ahead. It's not an even. Because once again, did it come back to exactly what we had? Nope. So if it's not even, it's not odd, then neither. And there's tons of neither equations in this one. So just because it's not even doesn't make it odd. Just because it's odd doesn't, you get what I'm doing. Okay? Now, so one thing that you always want to check for an odd function is if you ever have a constant, will that ever change? Will a constant ever change? No. No. So can anything with a constant ever be an odd function? Should it be an even function? As we saw in the previous example, it could. Yeah, because the fact of the matter, it stayed the same. Yes. Because remember, if it's an odd function, for it to be odd, it would have to be its opposite. Well, what is the opposite of this function? Distribute the negative through negative x cubed minus 3. So that's kind of what I was looking for to make it completely opposite. Does that answer your question?
Yeah.
Okay. All right. Hoping that you guys have better examples, because they're kind of basic. Little scallywag. Okay, so just the same thing though, we can tell if something is odd by its graph as well. Remember, x cubed was a odd function. And if you recall, it looks like this. It has the points. I'm going to just put some points on there so you can understand. It has the points 0, 0, 1, 1, 2, 8, right? If I put a 2 in, 2 cubed is 8. It also has the point -1, -1, -2, -8. Notice, look here. If I replace this input, or the x, with its opposite, do I get its opposite value? Replace it with its opposite value, do I get its opposite value? Right? Okay, so this is what we call symmetric about the origin. Symmetric about the origin. I think there's 2 in there. I swear. Is it 2M? People? Yeah.
How many guys feel your spelling goes down?
If you get it close, then you just spell check. That's how I feel these days. It's that way I get it close. Hey! How are you? I'll be fine. Good luck on your math test. Are you in 1010? You were in 1050. Good. Okay, let's try another one. I'm not going to tell you what it is. Go ahead and try to tell me what it is. Remembering that it doesn't matter whether you're checking for an even or an odd, you still have to do the same process of replacing it with a negative x, right? Oh, it's so hot here, guys. I'm dying. Anybody dying of heat stroke in here? All right. What do you guys find? Okay, let's check. I think some people said some correct words. Everybody there with me what I did? is it? It's direct opposite. So therefore it is, its direct opposite makes it an odd. Not. That's how she expresses herself. She's very nice and witty. Say what?
I was just wondering because I thought you had like both
I did. Didn't I replace x with negative x? That's what you have to replace. Answer your question? Now I just showed you via a graph that these points are working. So let's just try a point. Pick any point you want. Well, that means we plug 0 in, right? 0 for x, so that'd be 0 cubed, which is 0. 0 times 3 is 0. Minus 0 is 0. So yes, you do get the point 0, 0. That's really not the best one to pick. Let's pick 3. 3 cubed, 27. 27 times 3, 81. 81 minus 3, 78. You can't go 81 minus 3.
I didn't use it all.
Well, you gave me a weird one. So let's check. What would be, if it's an odd function, what should it be? Negative 3 comma negative 78, right? Let's try. Negative 3 cubed. Negative 27. Negative 27 times 3. Negative 81. Minus a minus 3, which makes it a plus 3. So negative 81 plus 3 is negative 7. Okay. On your test, if I ask you to prove if it is even or odd, you must show me that work. Not necessarily the point, but replacing it with a negative x. Okay? If I ask you to prove it via a graph, you could graph it and then tell me whether it is. But if I don't ask you to use the graph, I would like you to show it by finger. Make sense? Okay. All right. I think that's it. Oh, did I start one? And then yeah, right? All right. So let's replace him with a negative x, right? Thank you, brother. Negative x squared. X squared, right? So far, it looks like even, huh? Because nothing changed. But then, negative x becomes a... Is it exactly the same? Is it exactly its opposite? Is this a neither function? If we looked at this graph looks like this really quickly. Is that symmetrical about the y-axis? No. It's symmetrical about the vertices, right? It's vertical, not vertical. It's vertex. It is symmetrical about the vertex. If we fold it on the vertex, it would be symmetrical, but that's not the y-axis. Okay. You want to be careful if you ever have fraction ones that your top has a negative and your bottom has a negative. What does that come out to be? It comes out to be a positive. So you might want to see if you can pull it out, and then those guys cancel out. I don't want to go exactly. I like to let you guys try. But we should at least have a good 15 minutes of homework time you guys can try this. Okay? Nope, we got another one. So if Krista will go ahead and hand me 1-2, please.